So let's do an example of that. Let's say we want to find the partial fractions decomposition of x squared plus 2x over x squared plus 1 times x minus 1. Now, when you do these, they may not always be factored for you already, but I just went ahead and had it factored for you already because I'm just nice like that. Yeah. So we need to set this up. We have a quadratic factor. And if we have a quadratic factor in our denominator, we need to have a linear thing in our numerator. And then we have this linear term for which we only need a single constant term in the numerator. As always, we multiply through by our common denominator. Don't forget that this whole thing is being multiplied. So when you have a linear factor, you need to put parentheses around it so that you distribute everything to it. A lot of people make a mistake by not putting parentheses around it, and then they go to multiply and it doesn't work properly. So when we multiply through by the common denominator, in this term, the x squared plus 1 cancels out, leaving us with x minus 1. And over here, the x minus 1 cancels out, leaving us with x squared plus 1. So again, just like before, we have one convenient x value that we can plug in. If we plug in x equals 1, things will cancel out nicely. We have 1 squared plus 2 times 1, that gets us 3 on the left side. On the right side, we have a times 1 plus b, but then that's times 1 minus 1. So this is multiplied by 0, so that goes away. And then we just have c times 1 squared plus 1, so that's 2c. So we get that c equals 3 halves. Now, we can pick any x value we want. So you could plug in x equals 5 and x equals 7, and you'd get a system of equations that you could solve. But we can make this a little bit easier on ourselves. Notice that a is multiplied by x in here. So if we plug in x equals 0, that's going to get rid of a, and we already know c, so it'll let us solve for b. So if we plug in x equals 0, the left side is 0. On the right side, we have a times 0 plus b times 0 minus 1. So that's just negative 1 times b. And over here, 0 plus 1 is 1 times c. So from this, we get that b equals c, and we already know c is 3 halves. Now, if you wanted, you could plug in a third value for x, any value, and you'd get an equation, and it would have a, b, and c, but you already know b and c, so you can plug in and solve. But I notice I like to expand, at least mentally, and when I go to expand, on the right side, I get a times x squared plus bx minus ax minus b plus cx squared plus c. All right, so if I put together my terms, I get a plus c times x squared plus negative a plus b times x minus b plus c. And what I'm trying to solve for is a now, and there are a couple different ways I could go about doing that, but if I look at my quadratic terms, notice I have a coefficient of 1 over here, so we have 1 equals, my coefficient over here is a plus c, so 1 is equal to a plus c. We know c is 3 over 2, so we subtract 3 over 2 and get a is minus 1 half. Now, that is a bit longer than just plugging in another value, but when I'm doing this, on my own, I don't actually write this out. I just think about x squared, and I look at, okay, I've got a times x squared, c times x squared, and I go straight from this equation to here. So it winds up being a little bit less writing if you can do that in your head. Then we have our values. we can write them in and go for it. So minus 1/2 times x. And remember, whenever we have a fraction, we don't want a fraction within a fraction, so we put the denominator down into the denominator. So minus 1/2 x becomes minus x, and then it's over 2 times x squared plus 1. Conveniently, b has the same denominator, 3 over 2, so I can just say minus x plus 3. And then c is equal to 3 over 2, so that's plus 3 over 2 times x minus 1. And as always, you can double check. If you go into y equals, we can take our original expression, x squared plus 2x, divided by double parentheses x squared plus 1, x minus 1, and then put our answer into y2. Our answer was negative x plus 3, parentheses, over 2 times x squared plus 1, plus 3 over 2 times x minus 1. Go to my table, and look, they're all the same. So I did it right. Hooray! And then I've got my answer.